Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 1, Section 7, titled The Distributive Property. By the end of this video, you will have reviewed methods for using the distributive property simplifying algebraic expressions. In that regard, you will review the simplifying of numerical expressions, the use of multiplication property of -1. You will be reviewing the concept of combining like terms and writing expressions. Additionally, you will review a real-world problem using the distributive property combined with mental math. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel and leave a like if you find that it has been helpful. Thank you. Okay, so before we get into the meat of this review, let's go over some definitions. The first is a term. In an algebraic expression, a term is a number, a variable, or the product of one or more variables. A constant is a term that has no variable. That's a constant. A coefficient. A coefficient is a numerical factor of a term. And like terms have the same variable factors. Okay, that would be like 3a plus 5a. Those are like terms. The a's make them like. They're the same variable factors. Okay, good. Okay, objective 1, using the distributive property. So it says here, you can use the distributive property to multiply a sum or difference by a number. So let's take a look at a few of them here. Under this chart we have here, the distributive property. For every real number a, b, and c, a times the quantity b plus c is equal to a times b plus a times c. Or you can switch it around and kind of flip the a to the other side. They're showing it doesn't make any difference with the commutative nature of this multiplication. The quantity b plus c times a is equal to ba plus ca. And we can do it with subtraction. So that was the sum. Now, and then there's a difference. A times the quantity b minus c is equal to ab, which a times b, minus a times c, or ac. Or the quantity b minus c times a is equal to ba minus ca. So let's look at some examples. 5 times the quantity 20 plus 6 is equal to 5 times 20 plus 5 times 6. Or you could flip it around, the quantity 20 plus 6 times 5 is equal to 20 times 5 plus 6 times 5. And then we hit the last example here. 9 times the quantity 30 minus 2 is equal to 9 times 30 minus 9 times 2. Or flipping it around, moving the 9 to the other side, we could say the quantity 30 minus 2 times 9 is equal to 30 times 9 plus 2 times 9. Okay, example 1, simplifying a numerical expression. So they say here, you can use the distributive property to multiply some numbers using mental math. For instance, you can think of 102 as 100 plus 2, or you could think of 98 as 100 minus 2. So you kind of get the picture there. And so an example of that, it says, use the distributive property to simplify 34 times 102. So 34 times 102 right here, 34 times 102 is equal to 34 times the quantity 100 plus 2. Now you can see how it's going to get pretty easy now, because now we go 34 times 100 is 3,400, and 34 times 2 is 68. So guess what? The answer is 3,468. Makes that multiplication pretty easy, doesn't it? Okay, example 1, check your understanding. So you've been with me for a while, I'm hoping. It means I'd like you to stop the video and try these out on your own. And then when you come back, we'll work them together. I'll wait for you. Okay, assuming that you've done that, so let's give it a shot. It says simplify each expression. So problem A, 13 times 103. So how can we rewrite that one here? We can say that it's 13 times 100 plus 3. And if you do that, then it's 13 times 100. 13 times 100 plus 13 times 3. Okay, take it a step further. 1300 plus 3 times 13 is 39. So the answer here is going to be 1339. How about this one? 21 times 101. And that can be equal to 21 times 100 plus 1. Okay, or it could be equal to, then we can take it further, 21 times 100 plus 21 times 1. So 2100 plus 21 times 1 is 21. So how about 21? These are pretty easy, aren't they? How about 24 times 98? And that we can write as 24 times 100 minus 2. And when we do that, we say it's 24 times 100 minus 24 times 2. So now we have that equals 2400 minus 24 twice is 48, right? Minus 48. The final answer here is 24, right? Oh, excuse me. Oh, got ahead of myself. Is 23, let me clear that out. Sorry. 2352. 2400 minus 48 is 2352. Now the last one. So we have 15 times 99. And then we can say that that's equal to 15 times 100 minus 1. And then that can be equal to 15 times 100 minus 15 times 1. Last step here, 1500 minus 15. And then we have 1485. Okay, look at that again. Go over those if you want. If you need help with that, extra help, rewatch the video. Example 2, which is a real world problem here, says you can also use the distributive property in mental math to calculate costs. So how about this? Find the total cost of 8 sandwiches that cost $2.99 each. Yeah, it's a nice sandwich for $3. Anyway, so let's look at it. So what are we going to do? We're going to say, to start off, we're going to write the 8 times $2.99. Well, that's the same. That's equal to 8 times 3 minus 8 times what? 0.1? 0.01 rather? Okay, so we rewrote it using this mental math, taking the 2.99 apart and making it 3 and then minus 0.01, that 1 penny. So then we have 8 times 3 times 8 times 0.01. That's using distributive property. We've taken this and multiplied through, and that equals 24 minus 8 cents, 0.08. And then finally, that'll be $23.92. So the cost of 8 sandwiches costing $2.99 each is $23.92. Okay, example 2, check your understanding. So as you know, I'm going to ask you to stop the video and work this out yourself. What is the question? It says, find the cost of 6 pairs of socks that cost $2.95 per pair. So I'll wait for you. Okay, now that you're back, we're going to take a look at this. The first thing we're going to do is we're going to run it as 6 times $2.95. And then that's changing that into the mental math that we're going to use here. We're going to say 6 times $3. right? And it's minus, because this is less than $3, 0.05 or 5 cents for each one, right? So now we're going to multiply. We're going to use the distributive property. 6 times 3, 6 times 3 minus 6 times 0.05. Now we can do the multiplication. We're going to have 6 times 3 is 18, minus 6 times 5 is 0.30, 30 cents. And so the final answer then is what? Is 17, what? 30, a dollar minus 30, 70 cents. Dollars, right? So there's the answer to this, $17.70. So objective 2, simplifying algebraic expressions. So it says you can use the distributive property to simplify an algebraic expression. An algebraic expression in the simplest form has no grouping symbols. So what are the grouping symbols? Parentheses, square brackets, braces, the division sign, the line for the division, right? Those are all grouping symbols. In an algebraic expression, a term is a number, a variable, or the product of a number and one or more variables. So let's take a look at that. So here, the equation here, 6, right here, 6a squared minus 5ab plus 3b minus 12. Okay, that's the equation we're going to look at. So the constant we talked about, and a term can be a number. This constant right here is a number. This is a term. The minus 12 is a term. So a constant is a term that has no variables. You see, it's just 12, not 12a, 12b, just the number. Then we're going to look down here. A coefficient is the numerical factor of a term. So as you see here, the 6 of the 6a squared is a coefficient. 6 is the coefficient. The 5, okay, is a coefficient. And the 3 is a coefficient of the 3b. Okay, so those are the coefficients. So think of this is that 6a squared minus 5ab plus 3b plus, we have the quantity negative 12. So we've taken this negative sign right here, this negative sign right there, and now we've converted this to a positive and made the term negative. Okay, so the term that is the constant is now a negative 12. So like terms have the same variable factor. And they showed you this here just to get you used to the idea of taking positives and converting, taking a negative number and converting it to adding instead of leaving it as subtraction. Okay? So they have no variable factors. Like terms have, so what is a like term? If we had, they don't show it here, but a like term, 3b, we're going to see it in a second, plus 4b can be added together. Why? Because the b's are like, they're common variables, and you'd get 7b. But what if it was 3bc plus 4a, or just or? Let's make it even simpler. For b, well, we have this b equals, the b is in here. Why can't we use it? Well, the c makes this an unlike term from this one. If it had a c in this term over here, it'd be like. So you can't add these, okay? But like we added these two up here. So let's move on. I'm sure you're going to see it again on another slide. So objective 2b, which is the next slide from the objective 1 or 2a, still we're in simplifying algebraic expressions. So like terms have the same variable factors. I just showed that out in the previous term, but now we're going to go over it more thoroughly. So here, like terms. And why are they like terms? Right here, we can see that 3x and minus 2x, they're like terms. Why? Because they have the x in both terms. So those two can be added or subtracted. So it would be 3x minus 2x is x, or 1x. How about minus 5x squared and 9x squared? they're like terms because the x's are squared. If it was x squared and x, they're not like terms. You can't do it. You have to be exactly. Here's the next one, xy and minus or negative xy. Those are like terms because you have an x and a y. It doesn't matter if it's negative and positive. Okay. Xy minus xy is just 0. But the point is you can still add or subtract them. How about this one? It looks bigger, right? Minus 7x squared y cubed and 15x squared y cubed. These are like terms because we have x squared y cubed. They're identical. How about some terms that are not like terms? 8x and 7y. You have an x and a y. You can't add that. 5y and 2y squared. This is a square term, and this is a non-square term. You can't add them. You can't multiply. You can't do anything with them. You just have to leave them as they are. You can't put them together in any way because they're not the same. Okay? X squared y and xy squared. Again, they both have xy's, but one x is squared on one term and the y is squared on the other. They're not like terms. An algebraic expression in the simplest form has no like terms. So if you have more than one like term in an expression, you need to combine them somehow. Then you're complete. Then it's in the simplest form. So if the instructor, your teacher says, take it to the simplest form, you have to get rid of like terms by adding them, subtracting them, whatever. You can use the distributive property to combine like terms and then simplify the expression. Think of the distributive property as looking at here. BA plus CA is equal to B plus C times the quantity B plus C times A. So that's one method to use for combining like terms. Okay? Example 3, simplifying an expression. Simplify each expression. In problem A, 2 times the quantity, 5x plus 3. Well, let's simplify it. So we're going to get rid of, there's no grouping symbols, right? So we're going to get rid of the grouping symbols. So 2 times the quantity, 5x plus 3 is equal to what? 2 times the quantity 5x plus 2 times the quantity 3. And when you take care of the multiplication here, we're going to have 10x plus 2 times 3, 6. How about this one? The quantity 3b minus 2 times 1/3. So we have the quantity 3b minus 2 times 1/3. And what does that equal to? That equals to 3b times 1/3 minus 2 times 1/3. And then when we multiply that out, we get 3b times 1/3, or 3b divided by 3 is equal to b minus 2/3. 2 times 1 is 2 over 3, right? Minus 2/3. Okay, example 3, check your understanding. So like always, I'd like you to stop the video and work these out. And when you come back, we'll do them together. It says simplify each expression. So I'll wait for a couple seconds here, wait for you. Okay, I'm sure you stopped the video and did the work, so let's take a look at this. So what do we have with problem A, question A? 6m plus 5, the quantity m plus 5, right, is equal to what? It's equal to 6 times m plus 6 times 5. And then if we do the multiplication here, we get 6m plus 6 times 5 is 30. Okay? That's simplified. There's no parentheses. Let's do B. 2 times the quantity 3 minus 7t equals 2 times the quantity 3 minus 2 times the quantity 7t. Now we're going to multiply them. We're going to get 2 times 3 is 6 minus 2 times 7 is 14t. Okay, you good with that? You don't multiply each term. This is one term. 7t is one term. So you just multiply. It's like 7t plus 7t is 14t, right? Okay. How about this one? C. 0, the quantity 0.4 plus 1.1c times 3. And that equals what? So 0.4 times 3 plus 1.1c 1.1c times 3. And what does that equal to? That equals to 3 times 0.4 is 1.2, okay, plus 1.1 times 3 is plus 3.3c. Okay, example 4, using multiplication property of -1. Okay, to simplify an expression like negative the quantity 6x plus 4, it might make it easier as you're looking at it to think about the problem is to rewrite the expression as -1 times the quantity 6x plus 4, because that's what the negative sign implies. The negative here implies a -1, and we don't write it. Okay, we don't write it, but it's always there. So using multiplication property of -1. So to now simplify, negative 6x plus 4. It's the same problem. We're going to simplify it, right? So we're going to say negative the quantity 6x plus 4 is equal to -1 times the quantity 6x plus 4. And what does that equal to? That equals negative 6x minus 4, because you have to carry that negative through both terms. Okay? Example 4, check your understanding. Simplify each expression. So I'll wait for you to do it. You know what to do. Okay, I'll wait. When you come back, we'll do them together. Okay, I'm assuming you stopped the video, you did the work, and now we're going to do them together, okay? So let's start with problem A. Problem A is we have negative the quantity 2x plus 1, and we're going to say that that's equal to -1 times the quantity 2x plus 1. And now we're going to multiply this out using distributive property, right? Equals -1 times 2x is -2x, and -1 times +1 is -1. Okay? How about problem B? Writing it out. -7 minus 5b is equal to, we're going to change this using the property of multiplication, -1. So we have -1, oops, I'm going to change that. Okay, we do that one more time here. Equals -1 times 7 minus 5b. So what does that equal to? -1 times 7 is -7. And negative times a negative is a positive. So -1 times -5b is positive 5b. Okay. And the last one, problem C here, the quantity of, oh, see, they have actually done this for us. All right. So here, 3 minus 8a times the quantity of -1. And that equals -3, -3. I'm going to do something even different. Just to change, just to mix it up just a little bit. Just because they kind of mixed this up here by putting this paren in here. I'm going to say that we're going to do this. We're going to do, it's going to be 3 times -1. How's that? Minus 8a minus 8a times negative 1. So now we're going to equal this. This is going to be 3 times negative 1 is negative 3. And negative times a negative is a positive, plus 8a. Okay. Okay, example 5, combining like terms, simplify each expression. So let's we were talking about like terms in an earlier slide, so let's see if we can do a few of them here. So we'll start with problem A. So what do we got? We have 3x squared plus 5, plus 5x squared. Well, since these are like terms, the x squareds, we can add these. So that's going to be equal to 5 plus 3 is 8x squared. And let's try the problem B. We have negative 5c plus c. Well, these are both like terms right now, right? Because this is a 1. I'm going to rewrite it again. Negative 5c plus 1c. So negative 5 plus 1 is equal to what? Negative 5 plus 1 is negative 4. C is our answer. Okay, example 5, check your understanding. Simplify each expression. Why don't you go ahead and stop the video like we always do and try these on your own. When you come back, we will do them together. Give you some seconds here to stop it. Okay, so now I'm assuming you've stopped your video, you've done the work. I'm hoping you did, and you're back with me. So let's do problem A. Simplify each expression. So right here, problem A says 7y plus 6y is equal to, the y's make these common, they're like terms, so 7 and 3 is 13y. How about B? We have 3t minus t. So we can combine these right off the bat. This is 3t minus what? 3t minus 1t. Okay? So we can say that this is 2t. Problem C, minus 9w cubed minus 3w cubed. So right off the bat, these are like terms, we can add them and then take the sign of the negative sign, right? 9 and 3 is 12, so we're going to get 12w cubed, and it's negative because the signs here are negative, so it's negative 12w cubed. And finally, the last one, 8d plus d is equal to what? 8d plus, let's do this, 1d, just to see it a little differently. And that's 8 plus 1 is equal to 9d. Okay, good job. Example 6, writing an expression. So now we're going to write the expressions from out of words to what we had before with the distributive property. That's what we're really going to do here. So it says write an expression for 3 times the quantity x minus 5. So, and I've said this over and over and over again, right? When I read out the problems. So all I'm going to do is I'm going to say 3 times the quantity x minus 5. How's that? I think they did it, right? 7 times the quantity p plus 3. No matter how you do it, it's the quantity. Something times the quantity. I always put parentheses, right? Good. You're going to do a few on your own here because next we're going to go ahead and move on to doing your own. So watch. Okay. Directions. This is check your understanding now. Write an expression for each phrase. So there's 2 phrases here. Go ahead and do them yourself. Stop the video, try them yourself, and when you come back, then I'll do them with you. But I know you're going to get them perfectly. So, okay. Okay, I'm assuming you've stopped the video and you're back. So let's do them together. So what do we have? For A, we have negative 2 times the quantity t plus 7. Here we go. Negative 2 times the quantity t plus 7. How about The product of, that's multiplying, right? Product of means you're going to multiply probably the first term and the second term. The product of 14, you don't say times the quantity because it's the product of is times the quantity, right? Times 8 plus W. 14, the product of 14 and the product of 14, this term and that term. The product of A and B, that's the product of, right? This term times that term. So in our case, the product of 14 and the quantity 8 plus W is 14 times the quantity 8 plus W. Okie doke.